So first f prime of x, I need to use the quotient rule. The top prime is e to the x times the denominator minus the top times the denominator prime. Please do not multiply. Please factor e to the x plus 2 minus e to the x.
Can you switch the screens, please?
Oh. I didn't stop sharing. Oh, so I'm sorry. Thank you. Sorry. Let me start from scratch. Sorry. So I have to find the first derivative and then the second derivative. So for the first derivative, the top function prime times the denominator minus the top times the denominator prime, which is e to the x. I will factor out this, and then I have e to the x plus 2 minus e to the x over e to the x plus 2 squared. These two go away, so this is 2 e to the x over e to the x plus 2 squared. And this is just the first derivative. Now I have to find the second derivative and then discuss inflection points, concavity, yada yada. Any questions so far? Anyone? Any questions?
No questions.
Okay, so f prime, f double prime now, I will keep 2 outside. I don't need it. It's a constant in front of the function. Make it as easy as possible. The top prime is e to the x times the denominator minus e to the x times the denominator prime to e to the x plus 2 to 2 minus 1 times the inner function prime over e to the x plus 2 to the fourth. I cannot stress enough. Please do not multiply. Please do not multiply. Factor out e to the x, this, and then this, e to the x plus 2. So from the first term, I took out an e to the x and one of these two. So one is still left inside. Now I have to copy minus. And now let's see what is left from the second one. E to the x is outside. E to the x plus 2 is outside. So I only have 2 e to the x with minus in front. Yes? One goes away. And let's see what else is left. So we have e to the x. In here, I have negative e to the x plus 2 over e to the x plus 2 to the third. Set it, move the negative leading coefficient outside. Okay, so this is the second derivative. This is always positive, never 0. This is always positive, never 0. So for the second derivative to be 0, only this piece could be 0. This is always positive. Remember the graph? Remember the graph of e to the x? Always positive. And this is e to the x plus 2, so it's shifted up. So it starts like this, right? So this is always positive. This is always positive. So the only piece that could be 0 is e to the x minus 2 or e to the x to equal 2. And we know how to solve such an equation. How do we solve such an equation? And what is it? What type of equation is it?
Log root.
We apply log, but it's an exponential equation. Correct. So we apply natural log here and natural log here. X equals natural log 2. So this is a positive number, approximately natural log 2. 0.69. So all I need to do now is just look at the second derivative. And this function has absolutely no restrictions. This is always positive, never zero. So it's from negative infinity to infinity. And 0.69, and this is 0. I have to study the sign here and the sign here. Of what? Of this. But not this. And definitely not this. Who cares? They're positive. I'm not going to even bother. I'm not going to even look at them. So when I plug in 0, this is 1. 1 minus 2 is negative 1 with minus in front is positive. If I plug in whatever, 10, this will be positive with minus in front will be negative. So the function holds water between negative infinity and, to be exact, natural log 2, and does not hold water, concave downward, between natural log 2 and infinity. Very good question. Thank you. Is this okay?
I have more of a general question.
Yes, I'm ready.
So this homework for me, at least, was very hard. I went to the tutoring session and I was there for 3 hours and like we barely got through 5 problems. Is there any way that we could have any kind of like extra credit or something that we could do in addition to this homework assignment? Because I don't think I'm going to get a lot of points on this one.
So let me just explain something about the extra credit.